these are the organizational timeline for both things that are left for us, which is the technical paper presentation and the final project. And these are dates here, you could refer to them. So today is the initiation or the starting, the issuing of these things, official things, project description, both project description, both of them I call them projects. So by this date, by Tuesday, March 27th, you should choose the technical paper, and also you submit a one-liner weekly progress. So the idea is that we're going to have the first 2 weeks here for the technical paper and subsequent weeks for the project. But of course, I'm issuing both at the same time. You could work in parallel with both of them if you select to. Now, the technical papers will go into the details of what's available. I've uploaded a list of papers, and we'll talk about the guidelines. This is just the organizational dates. The presentation of the technical paper is on Tuesday, and the presentation, you're going to have a presentation in class. We're going to designate 7 minutes per person. And for those presentations, we're going to go into alphabetical order. I'll list the names in the alphabetical order. And your report for that presentation will be whatever you presented or the slides that you have. Typically in your presentation, you don't get to cover everything. Sometimes you have links, what have you, have more details. So that's your documentation that you submit for the technical paper, which is your slides. We don't want to make any more things of that. And then this is the date, April 5th. When I put the date here, that's by that date. The sooner, the better you select your public data set. Okay, so if you select it in the first week, that's wonderful. I think you should select the data set. We'll go through the guidelines about the type of data sets we're talking about. So the idea, every week you have a progress report, which is bullets or line or itemized, and you submit them through GitLab. And the next week, I just take the original one, I update it, I add more things, submit the next version of it, and so on. So we have a working document that has the history of your progress, and it's updated every week, okay? And you could lump them both for all activities, or you can have them separate. That's your choice. We'll talk about this one here, and then after that you have weekly progress, weekly progress, weekly progress. I have to note that on the March 24th, I'll be on travel until April 1st, attending a conference, the NVIDIA conference in San Jose. Hopefully we'll see what they're doing there and learn more about their latest activity and deployments or what have you. And I have any information, I'll bring it and share it with you, okay? Our final is set to be on Friday, the 4th. That's exam time slot for this class, and it's scheduled to be 7:45 to 9:45. If nobody had any objection, we could shift it to 8 to 10. Otherwise, we stick with the same time. If nobody has any other commitments, I'm assuming last day of exams, nobody has any more commitments, so we can start at 8 to 10. Again, for the final presentation, typically your presentation will be specified how many minutes, but typically we have roughly 8 minutes, and maybe 2 minutes for Q&A for each person. And everybody has to attend. And typically what I do in the final is that we have sheets, evaluation sheets, everybody participates, and we select the top 3 projects, in the class, and becomes basically ranking by everybody here. So we all participate. And you get a criterion of how you evaluate the project. You want to be all professional. You can either choose to include your presentation, all of you, or not to include your presentation when you evaluate it. That's okay. But you have to make a decision whether you're going to you value your own presentation or not. So this will be consistent. And so I think I'm debating right now whether we're going to have the top 5 or top 3, okay? I may actually just extend it because of the size of the class. We can have it top 5, okay? And this will be voted on. This has nothing to do with your grade. Your grade I'm responsible for, but this selection of the top presentation will be a class kind of activity that we've done historically, okay? So here's more details. Technical paper presentation. So instead of having a limited set for you, I say choose a technical paper that appeared in the last 2 years from, I have a list already on D2L for you. They can you choose from, but I'm not going to limit you to that list. If you don't find anything exciting on that list or fitting for you, you're welcome to go to the archive.org website and you key in some words, recurrent neural networks, convolutional neural networks, combination of those things, and you find maybe something that has appeals to you. You're also welcome to access any publicly available source in conferences of your things, as long as it has neural network, recurrent neural network, convolutional neural networks. In fact, I'm not going to limit your project. I'd like to have your project, obviously, to have recurrent neural networks. But for the technical papers, where you're free if you choose to focus only on convolutional networks. However, I'm going to give you a bonus if you include the RNN, any type of RNN in your project. So the bonus will be 2%. The technical paper part is 15% of your grade. You have a bonus points of 2 added if you choose RNN. RNN with convolutional networks, RNN alone. So if the paper deals with RNN, which is more current, more of interest, then you have this available bonus. That's your choice. Technical presentations will be set on Tuesday, April 1st, 2 weeks from today, in class. Your report will be taken as your slides or presentations. You could submit it by the following day. In case after your presentation you want to fine-tune things, clean up things, I'll give you that option, and you submit it by the following day. The presentation should address these things when you read the paper. Obviously, you need what the problem statement is, definition. So just briefly, you describe what the problem is about. So everybody knows what the definition of the problem, what the parameters, okay, in a succinct way, very brief. You don't have to be elaborate. You have limited time, so just bullets or specific things. These are the dimensions of the problem. It's almost in the category of the what we're talking about. Why it's important, significance. It addresses some important issue. It has experimental value. What does it address? So those are the things that you highlight. And then what approach have they followed? The how. How do they solve this problem in a unique way, in a new thing, in different ways? And lastly would be their evaluation, which is often in the conclusion, and also your evaluation. Is this paper quality paper? Did it miss something? Based on your knowledge, did you gain some new things from the paper? So those things you have to share, and you have to make evaluation. And here is just summary basically of things, and I'm going to have the presentation in normal increasing alphabetical order based on your last names, and I'll make the list there, okay? And presentations, you should plan for something like around 7 minutes, okay? Any questions on the technical presentations? Of course, when you choose your things, you have to declare it. And one of the issues is that you may actually choose one, you choose multiple, just in case same people select the same paper. So you rank them, you say, this is my first choice, second choice, third choice. I will do my best to meet your first choice. Unless there are two people asking for the same thing, then I'll toss a coin and see who's going to be the first choice. If not your first choice, will be second choice, and so on. Hopefully, people will spread out and not select the same papers. Okay? But just to avoid that issue, and once you have that, I confirm what your paper is, and I'll tally it and put it in a folder, and you basically own that particular paper in that category for your presentation. Okay? Any questions on the technical paper, which is the 2 weeks from today is the due date, and we have any questions you have until this Friday. You can ask any questions. Yes.
To confirm, I know you said it. I just want to reiterate that we can go to other sources like IEEE or something.
Absolutely.
As long as it's a neural network paper and preferably RNN.
Yep, absolutely. I'm going to open the floor for that and just not limit you and have you. I want you to be excited about the paper that you're doing. Yes.
I have 2 questions. So
Yep.
first, how are we submitting our choices?
I'm sorry?
How are we submitting our paper choices?
Yeah, so you could send an email to me. Yeah.
And then,
Maybe that's a faster way. Huh?
Okay. And then second question, are we planning on 7-minute presentation or 7 minutes including questions?
It's up to 7-minute presentation, up to. Okay. I think we're going to have, what are we going to have, like 90 minutes? Okay, so we have, I'm sorry?
I think it's 80 minutes for the course.
Yeah, 80 minutes, so I'm gonna budget on that. And I'll see, and I'll confirm that particular number, but right now I'm just in your preparation, think of that. And we're gonna ask how many people could attend before. Like, can we get earlier, and then, in case we need more time. We wanna make sure everybody's in class and everybody is presenting, okay? So if no objections, we may actually extend it a little bit in terms of the duration. But right now, roughly, that's the time. I'll do the calculation and confirm it, okay? And I'm assuming, and people present, can you come a little bit earlier? Can you come at 10, or you have a conflict?
Like 10 to 11:40 or...
For example, is that a possibility for everybody? Anybody having a conflict coming at 10, if need be, if we need it? Or staying later?
I would
Yes.
prefer coming at 10.
Okay.
I can come in 10.
You can come at 10?
10.
10.
Yeah,
Okay.
not 10.
Okay. So yeah, so we could maybe 10:10, we could begin 10:10, officially begin 10:10, the first presenters. I want to make sure everybody is here at that time. Yes. Because you're going to be evaluating the presentation both for the paper and for the project. Yes.
Are we going to send you our slides beforehand so we can have one computer that everyone uses, or are we going to bring our own laptop and just change out between presentations?
Well, I can get a laptop from Dex, typically similar to mine. I can have it available here.
I might be faster.
Yeah, absolutely. That's a good idea. Is that so you can bring a flash? Is that possible? I know some people maybe use different computers, but there shouldn't be a problem, right? Can we agree on that? Should I bring a computer and have it available here, and you bring your flash? Is that feasible? Sometimes we have glitches because somebody has a different. Yeah, right. Sorry.
No.
So I'm not gonna use my computer. I'm gonna have Dex computer because I know you guys are gonna bring some viruses, right? So Dex gonna be here. If there's a virus, they can handle it. So I'm gonna make sure I get both for the technical paper and the final project. We'll have a Dex computer here available. It's gonna be a Dell, okay? And sometimes in the past we had some people having some issues. Prepare for that. So it's gonna be a Dell computer. Get things on your flash. Before the class, you could go or put it all in if you like, or something like that. Very good idea. Yeah. Any other concerns, questions? And of course, we have Piazza for any Q&A that you could throw in. Some of you are not active in Piazza, as they should be, right? So any questions about the technical paper presentations? First 2 weeks. Okay. So then we move to the final project. And I'm saying use a model incorporating, it's still the same, should be conv, and this should be net, okay? I can't correct it now. Sometimes it goes by the name CNN, but I think the news company complained. I'm just kidding. Yeah. So people use CovNet. So I think if you want to be a true deep learning person, insist on CovNet. Don't use CNN anymore. And of course, we're going to focus on LSTM RNN types as part of the project. It's an important part. So I'm saying use public data, choose by this date. I'm giving you this leeway until April 5th, but I recommend you select your data the first week. While you're working on a technical paper, you just scan through that technique and look at it, because you need some preparation for it. Okay, so that's what I have. Explore, I think this should be also the 5th, I'm sorry here. So I'd like you to select the first week. I firmly recommend that you select the data set as soon as you can, okay? So this model here, I may actually, I've been thinking about it, is that maybe I'll give you some baseline model. The idea of the model, typically, it's best to have it, the first layers, like in the examples we've seen, they have ConvNet types, followed by recurrent neural network types, okay? For example, in the Keras examples, they had one example that has the bidirectional LSTM, another example that has purely ConvNet. So the immediate thought is to take that LSTM and sandwich it into that after the ConvNet. And you have a model that has two stages, ConvNet followed by LSTM. You could choose it to be bidirectional. Last year, people chose it to be bidirectional, or you could choose it regular, okay? I'm also working, and I'm going to have a prototype model for you, okay, that you can choose to build on that, or you can choose an alternate, okay? But basically, the model you work with would be has blocks of ConvNets, okay, followed by blocks of LSTM, one or more. Okay, that's the concept. And the reason is the ConvNet are good at classification and detection for 1D, 2D, 3D, meaning for regular signals, speech signals, for images, or for videos. So really, we use it like for encoding. It has a complex image with high dimensionality size, want to encode it into a vector. Okay? Once you have this encode of a sequence of vectors, now you hit it with RNN type, and certainly you're going to use the LSTM types. So that's the plan, and I'm going to give you, as I said, a prototype model that you can choose to use, build on it, ignore it, your choice. And then we're also going to give you our own module, which is we refer to as the SLIM module, which has reduced LSTMs, LSTM 1 to 5 and possibly more, which you in Keras, you just import it in Keras. Once you import in Keras, you have access to LSTM 1, 2, 3, 4, and 5. So we're going to have
the ones that we discussed earlier.
Yes.
Okay.
Yes. And maybe we'll walk through them again in the details of the project. So this is just the timeline, which is an overview of the project, and then we'll specifically look at the project details in a minute. So this is the top view, if you wish. And then, of course, this one-liner recurrent weekly status report, bulleted or itemized. Just say, this week, I explore this data. I've selected this data. This week, I did nothing because I'm busy with the technical papers. Okay? So just ongoing thing that you have, and we have documented. Thanks to GitLab, we're going to have every weekly things updated by law. Yes.
Do you want those on Tuesdays or Thursdays?
I have them on, I believe in the timeline is Tuesdays, yeah.
It says Tuesday on this slide, but if you scroll up, it says Thursdays.
Yeah, I think it's going to be weekly. It's going to be, yeah, we can decide.
Okay.
Okay, we can decide right now. Any preference, Tuesdays or Thursdays?
I'd say Thursday.
Okay, we'll go with Thursdays, okay?
Thursday.
So we'll correct that, make them due on Thursdays.
And then you said you want to upload it to GitLab,
I'm sorry?
the reports?
Yes, GitLab, yep. And let me repeat again, these weekly things will be submitted Thursdays, okay? And then, of course, we have the class presentation exam time slot, which is this slot, and that's the time. This is a loaded time for us. Okay, this is 2 hours for the final exam. We have 120 minutes for the class, okay? And I'm telling you the budget you're planning right now for 7 minutes, but we'll see how that is, whether we're going to increase it a little bit or decrease it. I'd like to leave at least 1 minute for Q&A. And we can stick with this time slot. We can just start at this time, end at this time, officially. We can shift it a little bit if need be. Okay? And after this exam, the same day, you need to submit by midnight your final report. And the reason I'm giving you that time is that in case you want to update things based on your presentation, fine-tune, whatever, you have that time, that optional time. You follow similar guidelines in the what, why, and how. You obviously have to comparison, benchmarks, tables. I've also uploaded, in fact, I have listed here, and they're available on D2L, papers of ours and others that you can look at the models. And also we gave you an IEEE form for a paper format. So your thinking of the paper will be concise. We don't want reports to go and left and right and whatever. We have a professional form of having a report, which is an IEEE standard paper format. You focus on the key important concepts, okay, and all uniform. Yes?
Do you have a LaTeX template? I think
We'll fetch one, yep.
Okay, perfect.
We'll fetch one for you, absolutely. So what I have right now is a Word, and we'll fetch, an IEEE LaTeX. Okay, so the conclusions, obviously in the conclusions, like in any other paper, when you look at the paper samples, there's pros and cons, what is achieved, what's missed, and your assessment of your results via the standards. And this red stuff is just repeating, and I'm talking about time allotted for each person is between 7 and 10. We'll fix that up. We'll fix it to a specific number so you know a specific number, and the final project's presentation will be in reverse alphabetical order. Okay, so your first beginning, you'll be last here. Okay? Okay. Any questions about the overview? If no questions of the overview, we're going to go to the contents about what the project is, more details. So here's the final project. So your final project uses the modified version of LSTM models, which we discussed in class, and they're included in these references as samples. These are archive references. And I have the other three, these are all our work, basically, which is an example of how a report should be, okay? We challenge you to have your results unique, and they are unique in a way because you have different models, and your comparison, your data will be So let me just not jump ahead and just walk through it in steps here. So we have the reference standard LSTM model, which is the working horse. Everybody swears by it, okay? In many applications has been successful in many things. And we have alternate versions that reduce to different degrees the parameters, okay? And we have some already published work. I gave you the archive versions where they make comparisons that you use it as a model reference or a baseline or comparisons, okay? And your choices of data, you can either select the data that's available already on Keras. So if I come here, this is the link, I gave you the link. If I come and click on that, oops, I don't have any internet, that's why. See if I can. Okay, so there's this link. Do it again. Okay, so this is exactly the location where this Newswire topics classification gives you how to access the data, and you could choose that data and read it. And everybody could choose that data or different people, okay? And it has 46 topics. So that's 46 classes, okay? And it gives you accessing the data. So that's one option. You may want to select other data types from any public data sets with multiple classes. The only condition you need to have multiple classes. That means the output has to be more than one output. Okay, not like the sentiment data that we worked on, which only 0, 1, right? So that's the only condition. And there's a streamlined data, obviously at Kaggle.com, which all the professionals, all the serious people about deep learning consult with and use. And many companies have already done the early work in preparing the data for deep learning. Okay? And it's also good to be linked with that type of data. So here's the Kaggle data set. And Kaggle has a wealth of information in terms of either the data set, it has a sample codes, kernels, they call them, and you can explore a lot of things if you want to, and you can walk through this data. Like in my other class, I talked about this data, and some people got excited at some choices here, and they wanted to explore this other data. And of course, you can have the data, some of this data, if not all, they were part of a competition. If you go to the competition, you're going to see some sample codes that people have used, typically in Keras or Python. You can also see what the reference performance is, how people performed with those codes. So there are a lot of different things, and some of you may be interested in some particular data. Okay? Anything that gets you excited is welcome. Okay? So there's a lot of different things. Of course, in this website, you can also choose to look at the competitions. And the competitions, they have archival competitions and new competitions. And the point, you want to look at that because if you look at some of this data, let's select, for example, just randomly, this one here, toxic, the only condition is that you need to make sure that it is multi-class. And so it gives you a lot of things, but what also it gives you is kernels, which are codes. And you look at the codes here that people provide for doing some particular things, and some of them are in Python, like this one and this one in Python, and some of them in R. So So there's a wealth of things associated with those things. It depends on your level of engagement and excitement and whatever. These are choices. So you have choice one, stick with Keras and get that data. Okay. Choice two, explore data that maybe is more relevant to your interest and excitement. And we encourage either one of those things. Your final report should be similar to the level of papers at the archive. So we've given you several references below which are published in the archive that gives you survey model. I have also some papers listed under the final project folder from the literature of other people as well. So you have a total of 8 papers. You can select one and look at it and try and model your paper structure like it in terms of the issues, okay? You don't have to read them all. You can just select, look at them and select this one here. I'm going to use this one as my prototype, and I want to make sure my paper is the same quality. So, so here's a model for LSTM, the basic LSTM, which we should internalize, we should know by heart right now, because everybody does in deep learning, okay? And it takes this part, which is the simple RNN, and it has these gate signals, which I separate them explicitly here, gating signals, and has this cell, memory cell, and this HT is the hidden unit description, and here's another layer for the output layer. And you may add to this output layer a softmax. Just make sure the outputs represent a probability. Okay? Any questions of that? Yes?
So this is the one that we should compare.
Yeah, this is the reference. Yeah.
Okay.
So this one, when you build your model, you build it as if you're working with this one here.
Okay.
And then you apply it to your data and do the best you can with the LSTM. The best we can, then at the end of the result, you're going to say, okay, here's the learning rate I have. And typically, I recommend a grid of learning rates, at least 3 learning rates. So if you have one that works well, have something to the left, something to the right, like in those papers. So that's reasonable, okay? And then you want to run this one here vis-a-vis your choice. I'm saying you choose at least one of the reduced forms. So last year, people selected multiple. There are people who selected them all because they just have a do loop and they have run all these things and get a comparison. Some people only focus on one and do more exhaustive grid search. Some people use a different, choices in terms of dropouts or different structure. So they have a study that explores, and these ideas sometimes parallel something that maybe either appear in the literature or somebody had that question about, what are the role of this particular element. Okay, so they all have gates, and our reduction, we uniformly reduce all of them together the same way. Of course, it's trivial. Somebody says, I can reduce one and not the others, and vice versa. You can have more possibilities. But uniformly, you can do the same action on all the gates for simplicity of coding. And these are the names that we label them. They're very trivial names, 1, 2, 3, 4, and 5. So I'm describing what they are here. I think we went through them. I assume that we all know them by heart. At least we have reference, we understood them. The 4 and 5, they're similar to the odd number 5, similar to 1. The only difference between 1 and 5 is that multiplication here is pointwise, and we replace the matrix by a vector u. And the even numbers 4 and 2, they're the same, except the multiplication here is replaced by a pointwise multiplication, which is mathematically known as Hadamard multiplication, and therefore the matrix UI became a vector UI. And the LSTM3 just uses only the bias. And obviously, these parameters are not fixed. These will be updated, and the update of these parameters all depend on the states, hidden units, and they have input signals in them, okay? So, for example, last year I've had one student who demonstrated that this 3 was outperforming the others in some data applications. Did an excellent job in thoroughly demonstrating in various ranges of parameters and did a surprising excellent work. Okay. So whatever you see in the sample papers, use it as a baseline or reference, but your results may be better in some cases, worse in other cases, because you're dealing with different data. Number 2, your model may not be the same, okay? Structure, you could have different layers or different structures, and your parameter range would be different, okay? So now, I'm telling you, if you get this stuff here, that's a publishable result. And the samples that you have here, the 3 samples, these are actually former students who were in a class 2 years ago. 2 years ago, when things were rough, we didn't even have the module. Okay, we had to build a module from scratch. And they explored a lot of different things. So my point is doable. Okay, and because of your different data set, different model, and different reduction models, I think this will be a differentiably unique stuff. So these are suggestions of how the structure, which is the same as in these samples, okay? Just itemize things that are self-evident in terms of introduction, literature review, which you base it on what you have. You can, and what you know, obviously you're not going to have an exhaustive research review. I think the selected papers we have for you already contain the level of overview of the literature for that particular topic. So that's a concise kind of reference, okay? So that should not be, because you can, once you have those papers that are already in the folder, which is by other people, and this set of papers, I think you cover the latest kind of thing. Your architecture is you just want to specify. So if you adopt the prototype that I supply as is, you just say, here's my architecture, I chose this one. If you add some layers, so this is, you define your architecture choices, okay? And it's always meaningful to justify when you insert a layer, you just make some sense of why you're doing that. You just want to don't have things. So typically,
even if it's your kind of intuition.
Yeah, I mean, you explain it, yeah. So it's just like, for example, I mean, the basic intuition that we have CovNet, because we intuitively feel CovNet will have an encoding of images into vectors, and then the time series that's generated will be, for prediction, will be the RNN. So that's the choice of having CovNet first before RNN. Somebody at some point may say, no, I want to start with RNN first, and they can justify it. Or the time series, because maybe my data was speech signals. I want to have a time series, and then maybe I use CovNet for classification. So the argument of justification makes sense. And if it's intuition, you just say intuitively, that's my justification for it. Okay? The data set, I think obviously every data set you have is going to have some description. You want to be succinct and just select the key features of that data set. You don't have to repeat the whole thing. You get references or links to where more details, but for your report or paper, you have to succinctly itemize the key features. Your results should be in tables or graphs. So if you look at the reference 8 papers that we have, they all have graphs for some cases, And then they summarize the total results into a table with a grid of parameters, okay? And the key thing is your conclusions and lessons learned. Lessons learned, for example, you discover, you find that, you thought with some hypotheses that maybe this model would be a better thing. You discover that it's worse or better, those kind of, how things worked or failed. So even the failing part is a learning experience if you bring it with a learning or success story. So, and of course, at the end, it always helps to, you list things that maybe a new investigator beyond, because of your time limits, your whatever, you can just itemize things, but be reasonable, okay? So you don't want to do the easy part and leave the big part for the next guy. So be reasonable, saying, here's another line that maybe is reasonable. So, these are optional. These are guidelines. These are not, required per se. Detailed reference is very important. Okay, so if you use any reference anywhere, you have to be careful about referencing that, listing it. You don't want to take something from some source and you're not listing it. That's very dangerous. Okay, so we want to avoid that. And in specific, I've listed here for you just sample papers of our activities here because the reduced models are only available here. And in the folder, I have other papers from the literature that has similar domains, not in this particular reduction, but different ways. Okay? Okay. So any questions? Anything that loose ends that we need to tighten here? So that the tasks that for you is number one, you select the technical papers from the sources that we identified, and you send me a list, rank list, 1, 2, 3 of your choices. I'll do my best to meet your first choice. Okay? Number two, you select the data set within this first week. My recommendation, of course, here we say until after. Some of you may say, I don't want to deal with the data set right now. I want to focus on the technical paper. That's your choice. My recommendation, you select the data set within this week because you need to read about it a little bit, feel more comfortable with it, try other things, exploration of the data set itself, which may be time consuming. And the final thing you have, I don't know how much money is left in your Google account. So you have 300 plus 50, that's what you started with. Presumably each one has access to the 300 plus 50. If there's an issue there, let me know. We may request something from Google again because they told us that option. I may have to submit something, a request like I've done last time. So if there's, let me know as early as possible. Okay, and some of you should have access to HPCC. So any questions? Any comments? And
Can I
if
ask a question about I'm good with this stuff, but in this first reference paper, there's a table that I have a question about.
Should we open it?
Sure, yes.
Okay. Any other questions? Should we go to this paper?
There's no other questions.
I hope I have access to it here.
It's just a question about how they compare or the benefit. So on the third page?
Yeah. Third page. 1, 2, and then 3. This is a very brief.
Actually, one page up.
Sorry?
One page up.
One up?
Yep, this page. So I read the description of the LSTM4 about the benefit of the pointwise multiplication over the matrix. So it reduces the intent was to reduce the parameters.
Yes.
So then there's a table 1 at the top of the right column. that displays
Table
the
1,
Yeah,
go up.
yep, right there.
Uh-huh.
And it displays the number of parameters as well as the times per epoch. So
Correct.
there's two
correct.
questions.
Yep.
First, I'm not sure what the times per epoch means, and secondly, I don't see anywhere else in the paper where it shows the benefit of the less parameters. I mean, I know we know intuitively
Well-
less parameters is more beneficial,
Yeah.
but so here they didn't show that in a way. I don't think.
Well, I mean, I see if I understood your question. Okay, so what this table says is that it lists the number of parameters
Correct.
on this side, and next to it, for the experiment when you run it, this particular module, how much for the same data set, same conditions, how much an epoch walking through one epoch takes, running one epoch when you do the training.
Oh,
Okay,
okay,
so
okay.
the
okay,
training-
okay.
When you do the training, it takes 14, I'm not sure, it says milliseconds. I
So
remember.
yeah, so I see it now, but initially I saw
Yeah.
times. Like I didn't see the
Oh,
seconds in
okay.
the parentheses.
Yeah, I think it's,
But it's supposed to be times.
yeah,
in
think,
seconds.
yeah, so
Okay.
it's,
A little.
I think, this paper, by the way, the source for this paper, it has more models.
Mm.
If you want to read more things, the other papers would be more maybe refined. So this, in terms of the description. But I think what this one is really counting seconds, and I think the description it wasn't right.
Then that answered my
Sure,
question.
yeah,
Then. Yeah, because I was wondering where does
Yeah.
it show the benefit of that?
Yeah. So the idea here is that for Model 3, it takes the least amount of time per epoch. And of course, if you say 100 epochs, you multiply this time by 100. That's how it takes for the training, going through 100 epochs. So yeah, so this is, this first paper, I have it for you because it has the 5 models.
Right, right.
That's the purpose of it.
Mm.
If you want to look at a model papers, you look at the other 3 papers.
Okay.
Okay?
I was just kind of looking at the different comparisons
Yeah.
of the outcomes.
Right. So here we're for the model. This is for this experiment. It tells you these are the total parameters used,
And then the time.
and you notice the parameters for 3, 4, and 5 the same because the 4 and 5 they use
The point wise.
point wise, and therefore they don't have a yeah. So. Right, so this is point wise, this has a bias, this doesn't have a bias, so these are the same parameters but this one is only the bias. And apparently with the bias only you have something like, 14 seconds per epoch. So I would recommend for this first reference, you only look at the definition of the models.
Right.
If you want to model your paper, you should look at the other 3 papers. If you want to follow it, or you look at the other 3 papers. So, very good question. I'm glad you brought it up. Yeah. So I have, so the ones, the 2, 3, and 4, these are prototypes that you could maybe follow in the description because we have more details there. This paper has less details but has 4 models.
Right.
And also we have another selected 3 papers in the folder as well by other researchers, top researchers, using different models. Okay? That gives you a flavor of what the community, in terms of preparing, succinct. So the paper is succinct because you decide about what things you're going to put there because you're limited typically to 4 or 5 pages.
Speaking of pages, did you mention a length for?
Yeah, I would recommend 4 pages.
4.
Yeah. So typically, IEEE standards would be 4 pages or 4 pages. Yeah. So you look at those 3 papers here, and you count how many pages, and you should stick with that pages. This one forces you to select only the essential, important, and also try to convey it in the best possible way. In the past, we used to have reports that are 100 pages. I've had people, so that's why we adopted this standard. Yeah.
It really forces you to squeeze out the fat and just
Exactly. So I've had reports over 100 pages, and and you try to find where the new contents are. That becomes a nightmare. Any questions, any comments? Anything that, and I encourage you to use Piazza. If any questions for the group, any comments. The submission, the weekly report, you could decide whether you want to have it as a text file, a Word file, a PDF file. Okay, if you do it every week, then just save the commands for it, and once you have it, you just and update that same file every time. Edit, commit, and then push. Okay. And you could lump all the activities in one technical report. So you can have the activities for the technical paper, which is only for the first 2 weeks, and then after that you just focus on the project. And it has bullets that has the progress reports showing up. Any questions, any comments? So I can take questions until Friday, then Saturday I'll be leaving, okay, for a week, attending this conference. Most likely I'll be too tied up with the activities there, and I'll be back fresh with new concepts, and I have in my schedule one presentation or two that probably I'll be using some of those Tuesdays after your technical papers to present reinforcement learning. So we're gonna 1 or 2 presentations dedicated to reinforcement learning. So I want to make sure before we end this class, at least we expose, even though it's not part of any activity. So just like, what is reinforcement learning? What's the latest? Initial concepts. So that will be important. So that will be done after the technical paper presentations during those weeks when you only have progress reports. So I'll choose Tuesdays to give those presentations. Any questions, any comments? Yes?
Will we not have anything during the class period next week then?
Next week, yes, there's nothing. Just progress report and your technical paper. Yeah. So if you have any questions on any of the stuff, please have them by Friday this week. So your choice of papers should be submitted as soon as possible this week. And I think we have, and the next thing is that data set. You can take longer, but I think the sooner the better. And I encourage you, to explore this other data set. You may find something appealing to you. Okay, any questions? Okay. If no questions, then we just end this session, this meeting. Okay, and